Today's lesson will be about solving one-step inequalities by multiplying and dividing. The target for this lesson is that you will be able to solve one-step inequalities using multiplication or division. So something to think about. A store advertises a sale where all DVDs are $5 each. You have $25 in your pocket to spend. Write and solve an inequality to find the number of DVDs you can buy. That's the goal of today's lesson, is to be able to solve a real-world application problem such as that. But before we can solve that problem, let's do a little bit of an investigation. So I have two investigations for us to complete together. We're going to follow the steps that were given to us, and we're going to make a conclusion about what happened. So investigation number 1. They want us to compare the numbers 5 and -3. Positive numbers were always bigger than negative numbers. So if I'm comparing these two, I would say 5 is greater than -3. Step 2, they want me to multiply both numbers by +2. So I'm just going to multiply the first number by 2, and I'll multiply the second number by 2. 5 times 2 is 10. -3 times 2 is -6. Finally, they want me to compare the numbers one more time. So I have a +10 and a -6. Again, positive numbers are greater than negative numbers, so 10 would be greater than -6. So now the question is, what did you notice? We had a statement, an inequality, and we multiplied it by a positive number. But the inequality, in a sense, didn't change. The left number was still greater than the right number. So what did we notice? The statement remained true. And that probably makes sense to you so far. In a previous lesson, we talked about adding and subtracting with inequalities, and we were able to add or subtract with no problem. Let's take a look at the second investigation. So again, step 1, they want us to compare the numbers 5 and -3. 5 is still greater than -3. That fact has not changed. Step 2, they want us to multiply both numbers by a -2. So very similar to what I did with the last set, I'm going to multiply both sides by -2. 5 times -2 is -10. Positive times a negative makes negative. On the right, -3 times -2 makes a +6. A negative times a negative makes positive. Then let's compare the numbers one more time. So now I have a -10 and a +6. We said positive numbers will always be greater than negative numbers. Therefore, -10 is less than 6. So what do we notice about this problem? In the last set, we multiplied by +2, and the inequality symbol remained the same. In this final set, we multiplied by a negative number, and the inequality symbol flipped. So the inequality symbol had to flip for it to remain true. And this is a huge key idea when you're working with inequalities. Mathematically, they're not too complicated to solve. Once we get to the examples and we start solving them, it'll be easy peasy. The tricky thing here is anytime you're multiplying or dividing by a negative number, we're going to have to flip the sign. So let me clear my screen and move on down to the final conclusion here, because this is the really important part. So important that I'm actually going to write it in red. So I would write this down on your paper. This is huge. Remember, whenever you multiply or divide by a negative number, you must flip or switch or rotate the inequality symbol. So instead of saying less than, it would turn into a greater than, or if it was a greater than, it would turn into a less than. That's what I mean by switch. They have to kind of flip-flop. All right, let's go through some examples. Example 1, solving a one-step inequality. So problem number 1 says x over 3 is greater than 1. So to solve this inequality, I find my symbol and I draw my line down the middle, keep my two sides separate. In order to isolate the x, I need to undo this divide by 3. And the opposite of that is to multiply by 3. Make sure when you're multiplying, you use a dot to represent that multiplication. Do not use x. So on the left, the times 3 and the divide by 3, it all cancels out. And I just bring down the x. 1 times 3 is 3. And then I multiplied by a positive number. So according to our investigation up at the top, nothing should really be affected. So I can just bring down my greater than symbol. And I'm good to go. My final answer has a variable, a symbol, and then the number, and it's written in the right order. So this is my correct final answer. In order to graph this, there is no underline under the symbol, so that tells me I use an open circle on 3. And then I want all of the numbers greater than 3. Greater than goes to the right, so I'm going to shade all the way to the end to the right and put an arrow on the end because that shading goes on forever. Problem number 2. This says negative 8n is greater than or equal to 16. So let's solve for n. Draw the line. Remember, there's secret multiplication going on here. So to undo this multiplication, I need to divide. And I divide by this negative 8. Notice I just said I am dividing by a negative 8. So just off the bat, to make myself, be careful with my notes, because I know I'm dividing by a negative, I always put like a little star or something here, just so I remember I have to switch my symbol. So instead of saying greater than or equal to, I automatically flip it and I make it say less than or equal to. You have to switch the symbol anytime you multiply or divide by a negative number. Then you can finish the problem. So the negative 8s will cancel. I drop down the n. And then 16 divided by negative 8 gives me negative 2. Positive divided by a negative will be a negative. This is my correct final answer. The letter comes first, so I'm good to go. And I did remember to flip the symbol. Flipping the symbol is super important. I know it sounds small, like you just forgot to flip the symbol, but it's actually a really big deal. If you forget to flip it, you're telling me that all of the right answers are wrong and all of the wrong answers are right, which doesn't make sense. That's confusing. You have to switch the symbol. To graph this, I would use a closed circle on negative 2. I know it's going to be closed because I have that little underline in my answer. And then when you're graphing, make sure you pay attention to what the final answer says, not the original problem. The final answer says all of the numbers less than negative 2, and less than always goes to the left. So I will shade all the way through and put an arrow on the end. Okay, let's do 2 more examples. So problem 3, this one says negative n over 1 is less than 1. So to solve, let's draw the line down the middle. In order to isolate the n, I need to undo this divide by negative 1. And the opposite of division is multiplication. So I'm going to multiply both sides by this negative and this 1. So let's do negative 1 on both sides. This negative 1 cancels with this negative 1, and I can bring down the n. 1 times negative 1, a positive times a negative makes it a negative, so it'll be negative 1. And then if I notice, I multiplied by a negative number. Anytime you multiply or divide by a negative number, do not forget to flip your sign. So instead of saying less than, I flip it and it becomes greater than. So final answer, n is greater than negative 1. To graph, I'm going to put an open circle on negative 1. I can't include it because it's not equal to. And based off my answer, I'm looking for numbers that are greater than -1. Greater always goes to the right. These are my bigger numbers. So all the way through with an arrow on the end. One more example. So problem number 4. In order to isolate the n, I need to undo that secret multiplication that's going on here. And to undo that multiplication, I'm going to divide. So I will divide both sides by 8. The good part is I'm dividing by a positive here. So far, I don't need to worry about anything tricky. 32 divided by 8 is 4. I divided by a positive, so no reason to switch the symbol. My 8s will cancel, and then I can drop down the n. This answer is 100% correct. However, it's not written in the proper format. Most of you will likely graph it wrong if you leave it like this. So we are requiring you to rewrite it so that way the letter comes first. And we've talked about this. We're going to rewrite it so the n comes first. Instead of saying less than, I'm going to switch it and make it say greater than or equal to, and then put the 4. So in this problem, I didn't switch it because I divided by a negative. I didn't have to worry about it in my solving. However, I did switch it when I rewrote it just because most of you will graph this answer correctly. Most of you would have graphed this answer wrong. So that's why we're requiring you to flip it. To graph, we're going to make sure we graph it based off this answer. So this answer says I need to put a closed circle on 4 because of that underline. And I'm looking for the numbers greater than 4. Greater than goes to the right. So shade all the way through with an arrow on the end. All right, think you got it? Time to do 2 checkpoint problems, and we'll go through them together. So problem number 1. This one says 100 is greater than or equal to -20w. So I'll draw my line down the middle. What should I do in order to solve for w? I need to divide, and I'm going to divide by the -20. So I'll do my division. 100 divided by -20 makes -5. Remember, a positive divided by a negative will be a negative. These 20s over here will cancel, so I can bring down the w. Should I switch my symbol at this point? Yes. If I look at my work, I divided by a negative number. Anytime you divide by a negative number, you have to switch your symbol. So instead of saying greater than, I flip it around and make it say less than or equal to. This answer is 100% correct. But again, most of you would probably graph that wrong. So we are requiring that you rewrite it so that way the letter comes first. So when I rewrite it, which one of these is the correct solution? It should be W is greater than or equal to -5. Again, both of those answers mean the same thing. This is the one that we want to graph on, just because most of you will graph this one correctly, no problem. So this was actually a double flip. I had to flip the symbol once because I divided by a negative, and then I reflipped it again because it was written in the correct order. This is pretty much as complicated as this lesson will get. So if you can understand the fact that we flipped it once because of the negative, and we flipped it again because we rewrote it, you're in really good shape for this lesson. All right, time to graph. Should I use an open or closed circle? Closed. The solution says that -5 is included, so I'm going to put a closed circle at -5. Based off this answer, what direction should I shade? I should shade to the right. I'm looking for all the numbers that are greater than -5. Greater than always goes to the right. One more problem. Let's take a look at problem number 2. What should I do in order to solve for k? I need to multiply by 2. So times 2, both sides. 2 times 3 is 6. The 2's on the right-hand side cancel, so I can drop down the k. Should I switch my inequality symbol at this point? No, I multiplied by a positive number. And from our investigation earlier, we learned that multiplying by a positive doesn't change anything. So I'm just going to bring down the greater than symbol. So far my answer says 6 is greater than K. Again, this answer is 100% correct, but it's not written in the right order. So I'm going to rewrite it so that way the K comes first. Which of these answers is rewritten in the correct format? Should say K is less than 6. To graph this, should I use an open or closed circle? Open. 6 is not part of the solution. It does not say equal to. Based off this answer, which direction should I shade? To the left. I'm looking for all the numbers that are less than 6. Less than always goes to the left. Let's go back and take a look at the word problem that we started today's lesson with. So it said a store advertises a sale where all DVDs are $5 each. You have $25 in your pocket to spend. Write and solve an inequality to find the number of DVDs you can buy. So on the left-hand side, we're going to talk about the money we're spending on DVDs. And if I go back and I look at the word problem, it says that DVDs were $5 each. Each is one of those keywords that means multiply. I don't know how many DVDs I'm buying, so I need to use a variable. We will say 5x. The other side of the inequality is going to represent the money in my pocket. And if I go back and I look at the word problem, it says you have $25 in your pocket. So the money in my pocket will be 25. The trick is picking the correct symbol. So the money that I'm spending on DVDs, should that be less than or greater than the money that is in my pocket? It should be less than. So I'm going to use the less than symbol. If I only have $25, I could spend less than that, but I can't go over $25. 25 would be my limit. Could I spend exactly $25? Yes. So because that's a possibility, I need to make sure that I put or equal to in my inequality. All right, how would I solve this inequality? This is an easy one. I would just divide both sides by 5. This will cancel. I divided by a positive 5, so I don't need to worry about flipping the symbol. I'm just going to say less than or equal to. And then 25 divided by 5 is 5. So the answer to my inequality is x is less than or equal to 5. To answer the question in a sentence, since I had to write and solve an inequality to find the number of DVDs that I could buy, I would say you could buy. And this was an inequality, so I'm not going to say exactly 5 DVDs. I would look to see what my inequality said. And it said x has to be less than. So I could buy 1, 2, 3, 4, or 5 DVDs because of that little underline. So to kind of convert that into a proper English sentence, I'm going to say you could buy up to 5 DVDs.